Have you ever thought about, like, I don't know, just how fast those online transactions really are?
Yeah,
Millions and millions every second, needing a response like that.
right.
Today, we're going deep, really deep into a system built for this exact monumental challenge, but, well, in the financial world.
Yeah, we're diving deep into a modern payment architecture, really built from scratch for speed, rock solid reliability and massive, massive scale.
Our guide for this,
Mm-hmm.
an in-depth analysis that peeked behind the curtain of one such system. Pretty fascinating stuff.
It is, it is.
As always, our goal is to uncover those core engineering principles and technologies that make this kind of high-performance processing possible. And, as we go through these ideas, we'll be connecting them to how Stonefly.com handles similar challenges.
For sure, and this deep dive is brought to you by Stonefly.com.
Stonefly.com.
For over 2 decades, Stonefly has been a pioneer, leading the way with solutions like SAN, NAS, S3 object storage, backup and disaster recovery, cloud, and, even cutting-edge AI and security applications and technology.
Oh.
So, as a technical expert at Stonefly, I'll be focusing on the engineering principles we discuss
Yeah.
and showing how Stonefly handles similar demands in data management, especially with, our advanced AI and cyber-resilient architecture.
Okay, so let's jump right in. What were the limitations of the old systems that made a total overhaul necessary? What were the pain points, the things that just weren't working?
The older systems, from what we understand, were stuck on traditional on-premise infrastructure.
Right.
Imagine trying to run a modern marathon, but you're using equipment from like 100 years ago.
So,
That created a whole bunch of bottlenecks.
yeah.
Scaling up to handle more and more transactions and adding new technologies became a real struggle.
Yeah.
And keeping up with today's need for speed, that instant response was a huge hurdle.
So the system really feeling the strain of modern demands. And I'm sure a lot of listeners remember this, trying to watch a movie online on dial-up.
Absolutely, yeah. And cloud readiness was another big factor.
Oh, right.
The benefits of cloud computing for better scaling and resilience are undeniable, something Stonefly's recognized and built into its approach to data management for years.
Makes sense.
The older systems just weren't agile enough to adapt quickly to new payment methods or changing regulations.
Right.
And security, rock-solid reliability, these are non-negotiables in finance.
Of course.
And just as crucial in data management, which is where Stonefly shines, they were areas that really needed major upgrades.
Yeah.
And at the most basic level, the sheer volume of digital transactions was simply too much for the old infrastructure to handle.
Right.
These are all challenges that Stonefly tackles head-on with its data management solutions, making sure customers can handle growing amounts of data securely and efficiently.
Okay, so a new approach was clearly needed.
Yeah.
And this new approach is centered around something called the Global Transaction Router, or GTR.
Yeah, the GTR.
What exactly does this central component do?
The GTR, that's the Global Transaction Router, it's like the brain of this new payment infrastructure. It's the first point of contact for everyone involved in a payment.
Yeah.
You can think of it as the air traffic control for the whole financial network.
Okay,
Very important.
I like that.
Yeah.
So who are these different players the GTR have to coordinate?
Yeah.
The key entities in this system.
So we've got acquirers, basically banks that work directly with merchants so they can accept card payments.
Okay, the merchant banks.
Right. And then you have processors, the companies that handle the technical flow of payment data.
Right, behind the scenes.
Exactly. Between merchants, acquirers, and the whole payment network.
Okay.
And finally, there are issuers, the banks or financial institutions that give us, the consumers, those payment cards.
Right, our credit cards.
They decide whether to approve or decline transactions based on, our funds or credit limit. Stonefly's data management solutions are kind of similar in a way. They offer that integrated functionality, ensuring seamless interaction across different data sources and platforms within an organization.
So the GTR is at the heart of it all, orchestrating everything.
Yeah.
Can you walk us through a typical transaction, how it flows through the GTR?
Sure. Imagine you're at a store using your card. The merchant, through their acquirer, sends a payment request.
Oh,
That request goes straight to the GTR.
got it.
The GTR's job is to find the fastest, most efficient way to process that transaction.
Okay.
It then routes the request to the right processor, which checks all the transaction details and sends it off to your issuing bank.
Right, your bank.
Exactly. The issuer checks if you have enough money and sends an approval or denial back through the GTR.
Man.
Finally, the merchant gets the response, and the immediate part of the transaction is done.
So the money actually moves later.
Yeah. The actual transfer of funds or settlement happens a bit later.
Interesting. So building this GTR, handling all that sensitive data in real time, that must have presented some unique challenges for the engineers.
Absolutely. Some major hurdles they had to overcome.
What were some of the specific challenges they faced?
Okay, so one was managing long-lived TCP sessions.
TCP sessions.
Yeah. Unlike those short bursts of connection we see on the web, older payment systems often use this standard called ISO 80583.
ISO 8583.
It's a financial messaging protocol that works over these persistent TCP connections. Keeping these connections alive and reliable for extended periods took some serious engineering.
It's like keeping thousands of phone lines open all the time.
Exactly, yeah. Good analogy. Another challenge was, well, ISO 8583 itself.
Right, the protocol.
While it's widely used in finance, it's also, how do I put this, a bit dated.
Okay.
The GTR had to be built to handle this, shall we say, classic way of communicating.
Right.
Then there's the challenge of those massive traffic spikes, think Black Friday, or those big online sales.
Everyone's buying at the same time.
Exactly. The system needed to scale up on the fly to handle those surges and do it smoothly.
Right.
And possibly the most critical, ensuring super low latency. Even tiny delays can lead to timeouts and a frustrating experience for everyone.
You sure?
These demands for constant uptime and high performance are very much in line with the challenges Stonefly takes on in data management.
I see.
Our architecture is designed specifically to handle heavy workloads with consistent performance.
Okay, some serious engineering feats then. Let's talk about how the GTR team tackled these challenges. Starting with their choice of programming language, Go or Golang. Why Go for such a critical system?
Choosing Go was a strategic move. A big reason was Go's concurrency model.
Concurrency.
Payment processing involves handling tons of connections at the same time, each needing immediate attention. Go's Go routines offer a really efficient way to manage all that without overwhelming the system's resources.
So it can do lots of things at once without breaking a sweat.
Exactly, very efficiently. And this focus on efficient parallel processing is a key principle in how Stonefly designs its own high-performance data management systems.
Okay, so it's built for multitasking. What else made Go so appealing?
Another big plus is Go's ahead-of-time compilation, or AOT.
AOT.
That means Go applications launch almost instantly. No need for time-consuming optimization when they start.
Okay.
In a system where every millisecond counts, like transaction processing,
Yeah.
that quick startup is crucial.
I see.
On top of that, Go's garbage collector is designed for low-latency applications.
Garbage collector.
It manages memory, and unlike some languages where garbage collection can cause unexpected pauses, Go's approach minimizes interruptions, ensuring smooth and predictable performance.
Smooth and predictable.
Yeah, that's what you want.
Absolutely.
Stonefly also prioritizes the use of efficient and robust technologies in its platforms to guarantee that optimal performance and responsiveness for critical data.
Makes sense. The next key design decision was gRPC over HTTP2 for communication within the system. Can you explain the benefits of that choice?
Sure. gRPC, short for gRPC Remote Procedure Calls, has a few key advantages over traditional HTTP communication.
Like what?
First, it uses protocol buffers, or protobuf, to encode messages instead of JSON. Protobuf leads to smaller messages and much faster encoding and decoding.
Yeah.
So when the GTR receives a message, maybe in that older ISO 8583 format, it quickly transforms it into a smaller, more efficient gRPC message using protobuf for internal processing.
Makes sense.
Second, gRPC runs on HTTP2, which allows multiplexing.
Multiplexing.
It means multiple requests and responses can be sent and received at the same time over a single TCP connection. In a system handling thousands of transactions in real time, this concurrent communication is crucial for maintaining low latency.
Okay, so smaller messages and simultaneous communication, a recipe for speed and efficiency in a high-demand environment.
Exactly. And Stonefly implements optimized communication protocols within its solutions, ensuring rapid and efficient data transfer and management across its functions.
The third key design decision was asynchronous logging.
Yeah, that's a good one.
How does that improve performance?
Okay, so in older systems, logging often happens synchronously.
There.
Every time the application needs to log something, it has to wait for that log to be written to disk or a database before moving on.
Okay.
In a system like the GTR, generating tons of log entries per second, This can become a huge bottleneck, really slowing down the transaction process. The GTR uses asynchronous logging to avoid this. Instead of directly writing to the final destination, logs are first written to a super fast in-memory buffer.
In memory.
Yeah, a separate process running in the background takes those buffered logs and writes them to disk or a database in batches.
There's like a dedicated note taker capturing everything without interrupting the main conversation.
Precisely. The team also used Go's slog library to build custom logging handlers. This gave them even more control over logging, like keeping logs in memory longer for more efficient batch writing,
Well,
and structuring the data for easier debugging. They also implemented log sampling.
log sampling.
Under extreme load, only a fraction of logs are recorded. It helps manage the huge volume of log data without missing important insights.
I see.
Stonefly uses sophisticated and efficient logging and monitoring within its data management and security offerings, providing full visibility without compromising performance.
Okay, beyond these fundamental choices, what specific optimization strategies did the engineers use to really squeeze out every bit of performance from the GTR?
Well, they had several key strategies. The first was rigorous profiling and benchmarking.
Profiling and benchmarking.
Yeah. Profiling involves looking at the code as it runs to identify bottlenecks, like slow sections of code or excessive resource usage.
I see.
The team used Go's built-in profiling tools, called peeproff, to measure these things. Benchmarking, on the other hand, means running controlled tests to measure the system's performance under different conditions, especially high transaction loads.
Right, to really stress test it.
Exactly. They simulated peak traffic scenarios to assess latency, throughput, and how well the system handled simulated failures. This cycle of profiling, finding bottlenecks, optimizing, and then benchmarking again is crucial for achieving and maintaining peak performance in any high-demand system.
So identify the slow parts and then test the fixes under pressure.
Absolutely.
A very scientific approach.
And Stonefly follows similarly rigorous testing and optimization processes for all its data management solutions,
Makes sense.
ensuring they meet the demanding needs of our customers.
Absolutely. What was the second optimization strategy?
The second one was using reader-writer mutexes.
Mutexes.
Yeah, it stands for mutual exclusion lock. It's a mechanism for managing access to shared data in a concurrent system. Prevents different parts of the program from messing with the same data at the same time, which could cause errors. A standard mutex gives exclusive access, so only one part of the program can have the lock at a time,
Okay.
locking others, even if they just want to read the data. The team used reader-writer mutexes instead. These are smarter locks that let multiple reads happen concurrently while ensuring exclusive access for writes.
So multiple readers, but only one writer.
That's the idea. And since a lot of what happens in transaction processing is reading data, this optimization really boosts efficiency.
I see.
Stonefly also implements similar mechanisms for data access and consistency in its architecture, boosting performance without sacrificing data integrity.
Clever. The final optimization strategy was being careful with the use of Go channels. Tell us about that.
Go channels are a powerful way for different parts of a Go program to communicate and share data safely.
Right.
While they're often the go-to solution for coordinating tasks, the team found that for ultra-high-speed transactions, using Go channels for the raw data actually added a little overhead and slowed things down.
Huh. That's surprising.
Channels have some internal queuing and synchronization, which can be efficient in general, but can also cause small delays.
I see.
They streamline the data flow, processing transactions more directly, minimizing those delays.
So sometimes the most direct path is indeed the fastest.
It's not just about the technologies you choose, but how you connect them, how the data flows.
Right.
And this highlights that need for efficiency, a key principle in Stonefly's data pathway designs and optimized architectures.
The article also talks about some operational best practices that are crucial for the GTR's success and reliability. What were those?
Yes, optimizing code is just one part of the picture. Maintaining performance and reliability in a life system requires good operational practices. The first is continuous performance testing for every single software release.
Every single one.
Even small code changes can impact performance, especially under heavy load. So every release goes through thorough performance testing. They run automated benchmarks to measure transaction speed, system response time, and resource usage. They also use load testing tools that simulate real-world traffic volumes to ensure the system can handle peak loads.
So it's a culture of constant testing and verification.
Exactly, even for tiny changes. The second practice is chaos testing.
Chaos testing.
Payment networks and critical data management systems need to be up and running 24/7, even when there are unexpected problems.
Like outages or failures.
Right. Chaos testing involves intentionally introducing failures or extreme conditions into the live system to see how it responds and recovers.
So they're trying to break it to make it stronger.
That's the idea. This proactive approach helps them find weaknesses and make sure the GTR is resilient.
Makes sense.
This proactive approach to resilience aligns with Stonefly's commitment to high availability and robust disaster recovery capabilities, like those in our Stonefly DR365V appliances.
And the final operational best practice.
The final one is an iterative development process. Instead of making big, infrequent updates to the GTR, the development team focuses on continuous improvement through small, incremental enhancements.
Yeah.
Developers constantly analyze performance data to find areas for optimization.
Right.
By deploying these small, well-tested updates frequently, they reduce the risk of big changes and ensure the system's performance, security, and scalability are constantly improving based on real-world use.
Small, frequent, data-driven improvements. A much more agile and less risky approach.
This philosophy is a core part of how Stonefly develops and maintains its Stonefly DR365V appliances and all our data management solutions. And remember, Stonefly has been serving enterprise customers across many sectors, including finance, healthcare, legal, education, and government, for over 2 decades.
Wow.
This demonstrates our long-standing commitment to providing reliable and continuously improving solutions. Our Stonefly DR365V, with its patented immutable storage and air-gapped backup, showcases our dedication to providing strong cyber resilience for vital data.
So, let's bring this all back to Stonefly. How do these principles of building a high-performance transaction processing system connect with Stonefly's expertise in data management?
While we've been talking about financial transactions, the underlying needs like low latency, high availability, strong security, and scalability are just as critical in data management,
Of course.
which is Stonefly.com's main focus. Just like the GTR has to handle millions of transactions super fast, organizations need to access, process, and protect huge amounts of data with speed and reliability.
Right.
Stonefly's entire architecture is built to meet these demands.
Okay.
Our AI integrations help optimize data management, while our cyber-resilient architecture, including our object lockdown technology, provides a robust layer of defense against modern threats like ransomware.
Protecting that data.
Exactly, ensuring the integrity and availability of critical data. Our Stonefly DR365V appliance, with its air-gapped and immutable storage, directly addresses the need for constant data access and protection, much like the GTR needs to process transactions without interruption.
It's fascinating how these engineering challenges, even in different fields, share so many core principles.
Absolutely. And speaking of robust, high-performance solutions, Stonefly has a special offer this month.
Oh.
For a limited time, you can get a Stonefly appliance with 70 TB of high-performance, fully redundant storage, expandable up to a massive 4 PB.
Wow.
It includes air-gapped and immutable features, compatible with solutions like Veeam, Rubrik, Commvault, and site recovery.
Nice.
Plus, it includes our object lockdown technology for top-notch ransomware protection, all for just $7,995.
That's quite an offer.
If you're looking to boost your data management with a solution built on performance, reliability, and security, contact our team at sales@stonefly.com for more information.
Sales@stonefly.com.
Stonefly has been a trusted provider in this field for over 20 years, serving enterprises across various industries.
So, to wrap up this deep dive, what are the key takeaways from our discussion about the GTR and how it relates to Stonefly?
The development of the GTR shows how important it is to make the right architectural choices, from picking a language like Go to using efficient communication like gRPC and implementing smart optimizations like asynchronous logging. These choices allowed them to build a system that can handle huge volumes of transactions with incredibly low latency and high fault tolerance.
Right.
And Stonefly.com has, for over 2 decades, focused on these same core engineering principles in developing our solutions for SAN, NAS, S3 object storage, backup and disaster recovery, cloud, AI, and security.
Okay.
Our commitment to robust engineering, Advanced features like AI-powered optimization and object lockdown technology, and our focus on cyber-resilient architectures all mean that our customers can manage their data with the same performance, reliability, and security as the American Express GTR.
Really interesting to see how similar engineering challenges are solved in different areas, from financial transactions to data management.
And it leads to an important thought for you, our listener. How are these ideas of resilience, high-speed processing, and strong security becoming vital for all types of data in today's digital world? Think about how much data you manage and the threats to its security and availability.
It's something to think about.
Stonefly.com is at the forefront of addressing these needs with our advanced AI and cyber-resilient architectures, including object lockdown technology. Explore what we offer at stonefly.com to see how we can help you navigate this complex digital landscape and protect your most valuable asset, your data.
Thanks for listening.